Right now your computer is doing 100 things at once. Running this video, drawing a browser, watching the keyboard, playing a sound. It feels like a machine of endless, dazzling variety. But down at the very center, the processor, the chip that actually runs everything, there's almost nothing going on. It doesn't know what a video is. It doesn't know what a browser is. It knows how to do one stupidly simple thing. And its whole trick, the entire reason your computer can do anything at all, is that it does that one thing over and over and over, billions of times every second. So what's that one thing? Here it is. The processor works through a list of tiny orders called instructions. Things like load this number, add these two, store the result. And it handles every one of them with the same 3 steps. First, it fetches, it grabs the next instruction, then it decodes, it works out what that instruction is actually asking for, then it executes, it does the thing, the add, the move, the compare. And then it goes right back to the start and does it again. Fetch, decode, execute. Fetch, decode, execute. That loop is the heartbeat of every computer that has ever existed. Nothing in here is clever, it's just fast. But where does that list of instructions come from? Here's the part that surprises people. The instructions live in memory, in RAM, right next to your data. And to the computer, there's no real difference between the two. An instruction isn't a special kind of thing, it's just a number. Add is a number. Load is a number. Your entire program, the browser, the game, the operating system itself, is nothing but a long list of numbers sitting in memory, waiting to be read one at a time. This idea is old. It goes back to 1945 to a report by John von Neumann. And it's the reason computers are general purpose, because the program is just data. You can load a different list of numbers and the exact machine becomes something completely new. So the instructions are just a list of numbers in memory. But how does the processor know which one is next? It keeps one more number off to the side called the program counter. That's its entire job. Hold the address of the next instruction. Fetch reads whatever the program counter points at, then nudges it forward by 1. Fetch, step forward. Fetch, step forward. That single counter, ticking upward, is the reason your code runs top to bottom, one line after another. The processor isn't really reading your program, it's just following one number that keeps counting up. Which raises a problem. If that counter only ever counts up, how does your code ever loop? How does an if skip ahead, or a function jump somewhere else entirely? The answer is beautifully blunt. Some instructions are allowed to reach over and change the program counter directly. Don't go to the next number, go to this one instead. That's a jump. And that's all a loop really is. At the bottom of it, an instruction that sets the counter back to the top, so the same block runs again. An if is just a jump that only happens when some condition is true. Every loop, every branch, every function call, and every program you have ever run, it is all this. Writing a number into the counter to change what comes next. The machine never really loops, it just keeps counting. You only get to decide what it counts toward. One thing is missing. What actually makes the loop go? What pushes it from one step to the next? A clock. Not a clock that tells time, a clock that keeps the beat. Tucked inside your computer is a tiny quartz crystal that vibrates at an incredibly steady rate when you run electricity through it. That vibration becomes a pulse. Tick, tick, tick. And every part of the processor moves in lockstep with it. One tick, the machine takes a step. Next tick, the next step. And how fast does it tick? Billions of times per second. That number, the ticks per second, is the gigahertz on the box. So 3 gigahertz means 3 billion ticks every single second. That is how fast a computer. Not how clever the loop is, just how many times it can take one more step. Okay, so let's take a step back and look at the whole thing, right? There's no magic here. The most powerful chip you own is doing the dumbest possible job. Fetch a number, figure out what it means, do it, count forward, over and over, a few billion times a second, until you switch it off. Every frame of every game, every letter you type, every video you stream, all of it is this one tiny loop. Runs so fast it turns into a browser, a song, a whole world. Now, I've shown you the clean version. A real processor cheats to go faster. It works on several instructions at once, and it turns out it actually spends a shocking amount of time just waiting. But that's a story for another video. Underneath all of it, the heartbeat never changes. Fetch, decode, execute again. Everything you just figured out rests on something deeper, and that's the next video, so start there. Would you rather understand your computer than just use it? Then subscribe, and I'll see you next time, further down the stack.